So yeah, today we'll talk about steganography. And you might be wondering, what is this? Think about it sounds kind of like a kind of like a cryptography, but there is one main difference. Is that in cryptography it's a function. We have some message and a key, and we like use the key to somehow like jumble the message together, so it won't be the same message, but it will still, but it will some man in the middle will be able to see that it is something of value because it's been hidden. So with steganography, the goal is to embed the message within some other payload. So, and someone in the middle of our communication line won't be able to see that it's actually like something of value. So here's an example. We have Alice and Bob. They are the two parties communicating, and there's also Chad. Chad he's the eavesdropper. You're funny. And Alice wants to send a message to Bob, but she knows that Chad is listening. So this is how it looks like when she sends some message that is encrypted. Bob will see it, and it's like he might want to look further into it, maybe try to brute force. And it's not really our goal. Our goal is to make Bob like ignoring it. So let's say Alice takes an image, uses steganography to encrypt, to decode, to encode the message inside the image, and the image should look the same way. And just pretty much Chad will see it and ignore it. And then Bob will just get the message. So yeah. And now we know that Alice really likes fonts. So just before we jump into the demo, I won't tell you what tools to use. I think you should, it's like a CTF, but a bit easier. I will show you the solution, but I want to think about, there is in a file that you send, you have a metadata with some protocol. You have the data, like what you see in the file. And yeah, and you might want to think about how you can combine that with a cryptography to actually brute force. Like maybe you're putting an encrypted message in the image, so you don't know that it's something of value. So without further ado, let's look at the first challenge. So the first challenge, okay, actually, I'll stop. We have this picture. Let's open it up. It is a bird. The flag is inside. Somewhere here, there is a flag. Your task is to find the flag. And think about the data and the metadata. Yeah, so I think in a CTF, let's say we are not really, we don't know anything about this, like anything about images. Let's learn about how they are stored, what is the metadata behind of an image, what is the protocol. And it's pretty much a game of Googling. Like it can happen that in CTF you have no idea and you have to Google. So yeah. And the name of the challenge is also a clue. I try to also put like a stupid clue that in my head works, but every CTF is this way. So I think this challenge with the bird, it's called excondition. It somehow relates to how an image is stored. If you need any help, don't ask us on Zoom, Discord, or in person. No worries. You know what? At the meantime, I'll show you the challenge with the PDF. It's called PDF Fetish. It's also a reason why I call this cringe name. it's cringe. It has a meaning if you know how I made this PDF. It all makes sense. So I'll just share my screen for a second, and I'll show you about this PDF. So this challenge, you get a PDF. It's really fancy. So here's the PDF. It's really fancy. The flag is somewhere here. And again, this concept of metadata and data, it's really important because the flag is in the file, but you might not be able to see it immediately. You might need to dig deeper into how PDF stores the data and the metadata. But yeah. So in the meantime, I'll also show you the audio challenge. So all of these names have some meaning to how I made the challenge or how I'm supposed to solve it. But yeah, so all of these files I got from Wikimedia, so it's all free to use under Creative Commons. But so in this case, the flag is somewhere in the file, but it's not really immediate how you get it. So as I started, pick one of those and try to find some information about how data and metadata are stored, because it's a different protocol. So yeah, see you in 5 minutes. Yeah, so I think probably time to show you the solution for the first challenge with the PDF. So that's a background on how I made it, so it's make more sense. So does anybody know LaTeX by any chance? But it's a language where you can define the typeset of the document, and it will compile to a PDF. And let's just share a screen. Yeah. So yeah, so we have this is a PDF file, and in the browser, if we open it, there are two ways to do it. One is a browser, if you want. So in every PDF file, you can view the metadata by going to this and properties, and the flag is right here. So once you know this thing, you will do it on every PDF file, because like if you get like some slides, you can immediately know if they're using PowerPoint to generate it, because like you know how I made it, like LaTeX and the like LaTeX compiler. So it's really fun to know this detail. And if you are a command line type of person, you can just use the command PDF info, and it will give you the same amount of the same data. And this is available via the popular dash, in Kali it's called the popular dash utils package. You can get this command, and other ones we will use this family of commands later on. But yeah, so the next one, I'll get my notes from my phone. Just a second. So next one, we have an image of a bird, I think it was. So yeah, now if you know, it's called excondition, a stupid pun of like xif, the protocol of storing metadata in images. And there is a cool tool. I think it is available on Kali. I'm just using a Mac, of course, for now. Xif tool. Just give it the file name. It will print anything about this picture in the metadata, and this will be stored. Let's say you take a picture with your phone. The phone would store the location of the picture, like the latitude and the longitude. And in this case, I put a flag in the comment field. So let's just type this to grep. And here's the second flag. So this type of style with the exif format is really common in CTFs, like it's just one comment pipe to grep really easy. And yeah, so the challenge with the MP3, it's called ididid because the protocol for storing metadata in MP3 is called ID3. And there is a command called ID3 info. And let's say, and here's your flag. Now on Kali, I think you need to install the package called libid3-tools to get this command. And I've never really seen this type of in CTF, but feel like it could be really cool. And yeah, although you might think that it's really annoying because like you need to guess what tool I used to guess, like it's all about guessing my tool that I used to make the challenge. But I feel like the basics is just this, but if the challenge gets more complex, this could be the first step to get to the next steps of the challenge. So I could lace like multiple steps of you getting to the flag. And it just happened to be that the first step is to guess my tool, the tool that I use, or the protocol of the metadata. So the next challenge is this thing that I can't really pronounce, but we'll get a second image of a bird. And this time, the picture, the flag isn't really in the metadata. It's somewhere else. It's actually inside. It's like in the slides we talked about that you can embed the text in the data. This picture actually contains the text on the binary level, and you need to use some tool to reverse the process and extract the data from the image, which will be a file called flag.txt. And the name of the challenge is also a clue. So let's just stop the share and I'll walk around if you need any help. Okay, does anybody have any questions? Those camera? Which ones? Oh, those? Yeah, I don't know. You can ask him. Leo, are you alive?
Mostly.
Great. Yeah. Jamie is asking. So yeah. Yeah. Okay. No worries. Let's just move on to the next challenge. Okay. So with this challenge, it's a really dumb name, just putting steghide in reverse. And steghide is a tool used too much in CTFs, but it's really useful. It's just you can embed a text file. Okay, I think for this one, I might have to boot up Kali. So I'll do it right away. Yeah, so if you don't know how to use the steghide, there is a useful manual at the official website or at the man page for steghide. And yeah, I'm just booting up Kali. Let's do it. Yeah, so here's Kali booting up. And so, yeah, we have the most standard way of using steghide is just use steghide -p, and so the -p is the passphrase. For this one is empty because I didn't give you any passphrase, but just another way to protect your data when you're sending it. And yeah, I think this one. Oh, yeah, steghide extract. My bad. So extract. Yeah, so, and it made a new file for us. So this is the original file name. If you want to, there is a flag in the man page that you can look up to change the file name before you make it in the command. But for now, here's the flag. And this is, now this is like really cheesy because you just need to know stegguide, but in CTF, if they're really clever, they can layer it up on top of the steps. So it's really cumbersome to find a flag. But yeah, so the picture would look really simple, but the flag is invisible to our eyes. And yeah, the next challenge is just introduce the challenge. It's on top of that, same idea, but now you need to crack the password. So the password, so you need to figure out, if you don't know about password brute forcing, you should find out what is the most common list that people try to brute force passwords and what tools. And there is a tool, the challenge name is a clue. And yeah, good luck. I'll catch up in maybe 10 minutes. Yeah. So let's look at so
the Kali VM be able to handle even with that word list?
If it won't work, so I think in this challenge we can use multiple tools. Yeah, so I'll just show on the screen. So we have in my solution, I use a tool called stegcracker, which is mainly can be slower, but I put it in because it's really easy to get from the Kali repositories. So yeah, so if you don't have it, you can just run sudo apt install stegcracker, and you need to give stegcracker the file and the word list. Actually, let's get the file first. So yeah, replaced. Why not? What was the file name? Oh, stack. Okay. So this is a JPEG, and we need to use a word list. The most common one is called rockyou.txt. It's from a data breach of passwords, and I think it's built into Kali, but it's compressed. So first we need to uncompress it. So we use sudo gnzip user share word lists, and it will be compressed to the same location, but without the .gz in the end. And we can use stegcracker. Now, if it won't work on this VM, I think we can show you another tool. I think Elias can show us as use stegseek, which is faster, but sadly not on the Kali distro. So we need to use stegcracker, and we need to give it the file to crack and the word list. So this was user share word lists rockyou.txt. Now it might, if it would crash, which might have happened, I will pass it over to Elias, and he can show us.
Maybe it's just my machine.
It could be okay. It could be like that at home I tested it on my PC, which is not really a VM. So it could be my fault, but in theory it should take like a minute, because I chose like a really early item in the list. But if it works, you will see like a zero code, a zero return code, and you should get the output to a file with like the file name .out. So yeah. In the meantime, if you know how to use stegseek, it might be more worth it because it's like faster, and we can only hope that Kali people will put it in their repositories. But yeah, at the meantime, let's maybe feature the next challenge. This one actually is really fun, and I've never seen this in a CTF. If you know LaTeX, you might know this name from LaTeX. So the goal of this, you get a PDF, you get two pictures. The flag is embedded in the pictures, but you need to get the pictures out of the PDF. It is possible with a specific tool using the popular family of tools I mentioned before. And yeah, so let's just save it. Let's show you the PDF file. And what is it? Yeah, so here's the PDF. We have Stanley Kubrick, the known director, and Mutahar. They're the same person, but we don't really care about this part. Although Muta is really funny, we care about we need to get these two files out of the PDF. Yeah, so I'll give you some time to find how to do it, and it's really useful once you if you get like some assignment and you want to use the image in the PDF, you just take it out of the PDF and put it. Like what do you mean?
There's something where you specify a window, the PDF, and then the page and the window, the coordinates, and build extra.
Oh yeah.
That part.
But you. Okay, I might not be aware of this thing, but in this case, I want to get a JPEG of this out of it. Like I want to get this JPEG. So like I want to get these two files as a JPEG on my own on my local file system. And if you already installed the popular, I think it's called popular util. Okay, I look it up, but it's if you search, like do apt search popular, like POPPLER. It's like a family of tools. Like you have PDF images, PDF Unite. It's really cool if you want to manipulate PDF. And in these tools, you have like a tool to extract all of the images from a PDF. Yeah. So I'll come back in 10 minutes. Also, a note, you might want to check out in Kali, it's called the popular-utils package. It's really useful. And I think it might be included in, there's a meta package called forensics in Kali. It might be in there already if you have the forensics package installed. Oh, and also in the meantime, if you don't want to do this PDF challenge, I have some other challenge. The last one, you will get like a binary. It has some data in the binary, which we embed the message in the data. And you need to find out what kind of data it is. Let's just download it. Yeah, so this challenge, we're giving you a binary. And you can use Gitra, although I don't know how far it will get you. But this file is just a normal Linux ELF binary. And when you open it, you might see that there is a giant blob of data and the main function. That's it. And your task is to find out how to extract this data from the binary and go further.
Hello, hello. All right. Who already tried to use a stegcracker? All right, a couple of you. Okay, you're using it now. Okay, I'm gonna show you another tool that I believe is from the same developers. The stegcracker was like the previous one, and then they developed a better one called stegseek, which that one allows you to run about 14 million lines in 1.21 seconds, according to the reports, which I find extremely efficient because stegcracker only takes 5 hours, just 5 hours to do the same work. So I'm just gonna share screen and you guys will be able to see this in practice. Yeah, I find it extremely, how to say it, efficient. So just give me a quick second. All right. Yeah, all right. That's my screen. I'll zoom in soon. I just need to download the file real quick. All right. So for those that were running a stegcracker and they got tired or thought that it's not possible to get it there, so we're gonna run this command called stegseek. Honestly, you don't even need to put this. Sometimes it's just like stegseek, your file, and the word list. In my case, I'm using the Rocky word list because it's like, well, very popular for like challenges like this. So I'm just gonna press play. Let's see how long it takes. That's done. Pretty much. Yeah, that's all it took. Real quick, right? So if I do ls and then I see like this file over here, and I just cut the file. There you go. So that's the key. Nice, huh? Yeah. So feel free to try stegseek. That's pretty much it. All right. So there are some options on a stegseek over here. As you can see, there is crack, which is it just uses a default mode. Honestly, you don't even need to specify it. This is the default, which means it will take a word list and then it will just try to crack it. That's it. And then there is it, which is a different one, and it just tries like different patterns. But honestly, for most cases, you wouldn't need it.
Yeah. So yeah, so I think if stegcracker might be too slow, but it's fine, up to you. So the next challenge, I showed you the PDF. You have 2 images, you need to give them out to PDF. So you could, this is like the layering of the difficulties. So like you need to like combine multiple steps in the right order to get the flag out. So yeah, so I was mentioning the popular utilities. I think you can get them by doing sudo apt installed popular utils if you don't have it installed. And in there is a package, there's a command called PDF images, which would, it used to get images out of a PDF. And you need to, the command sequence is really annoying, but it's really useful command. So I think the name is, yeah, includegraphics. And so here's the PDF. Now we need to run PDF images, and I think what's the graphics -j. I think this should be enough. Yeah, and now if you look in, we have 2 JPEGs. And I think this should be the same JPEGs in the image. So if you know LaTeX, you might know about ticks. This won't work on ticks. It only works on a JPEG or PNG, like a file that you, and ticks isn't really a file, but nevertheless,
Can you protect your own LaTeX file from
you don't use the images, you use something else. Like if you, let's say in a PDF, you're going to, yeah, I mean, you can use ticks. But if you do /includegraphics and a file, it will be here. So you need to use some other form of data but yeah. Yeah, so from this moment on, you can just use any other steganographic tools to extract this data, the flag for, let's say, exif tool, steghide. And in CCF, the the author of the challenge could really layer up those steps, so it would be really cumbersome. And in this case, I put only 2 steps, but it could be more. So I know that because I made it, I know that it's not in the metadata, so just use steghide, extract, and what was it? Oh yeah, I think so. In CTF, there could be a passphrase. So yeah, so you have to do both files to get the both half of the flag. And here's the flag. Oh wait, flag one txt and flag 2. Those are both halves of the flag. That when you combine together, you get the flag of the challenge, pretty much. So yeah, so I think it's pretty cool, and obviously it's useful in some assignments if you want to get the features to use it on your own assignment, like from the question in the PDF, but up to you. And yeah, for the last challenge, when we get the binary, so let's think called Robin. It's called Robin because the image embedded in the binary is like a picture of Robin, of a bird. And one useful tool to actually use a tool called beanwalk, which is like a hint in the challenge question. So you just do -d to detect. If it's not that, I have some notes I can use. Yeah, it's probably something cumbersome. Yeah, okay, let's see. Oh yeah, -e. So don't be like me, you look at the map page. Yeah, so this is a table of everything that the format, that it knows about the format. So we have some EXIF metadata. We have some JPEG. Yeah, so we have some JPEG with EXIF metadata, and we have some binary. Oh, by the way, if you run the, probably should give it a, yeah, okay. chmod +x. It tells you how big the file is, which is, so this is in the main function that I put in the C binary, in the C code. Just like some clue of how big the binary, the actual image, the JPEG is. And you should look at the man page further, and you can use beanwalk again to -d, and the argument you need to give it JPEG image, really weird name. So this would extract the binary, the image to JPEG. And I think now we should have a Robin in my notes. Yeah, so it's in this folder.
/d just doing pattern matching.
Actually, okay, to be fair, I don't know why the logic behind this argument of this of beanwalk, but I think in my head it just say to find every JPEG blob in the binary and to just pull it out of into its own file. And yeah, and yeah. So it's, so this folder name is from the name of the binary. So because we have a clue that it has some EXIF metadata, we can start with an EXIF tool. And let's say, actually, it's too large. Let's just use grep to pipe. And here's the flag. But obviously, I could have picked a different scheme to actually put the flag in. I could have picked like some steg hide. I could have pretty much, I could have chosen a different file. I could have putting a passphrase. So just in order to check out all options. But in this case, yeah, pretty cool. And if you want, I can show you how I made it. So so this makefile is just how I made it. So we can, so this is the URL of the file. So just say dirt. And you can convert any binary file, like any file, to a binary object, like -o, with the GNU linker, like LD. This will convert the binary, like the JPEG, to a binary object. And now we can use the C compiler of GNU to compile the C code. Actually, here's the C code, just to print the size of the binary. And this is the variable to know the boundary of the blob of the JPEG. And I think these names are pretty important to memorize, to know what they will be, because I think there is, I read some way of like I think it was G object, no. Okay, I think for different time, if you want me to explain how I made this challenge, I can do so later on. So I'm putting like some reference to how I learned about it. But yeah. So if you have any questions, you feel welcome to ask us. And yeah.